Rightio guys, this is something for school that I'm doing, but I'm also just uploading it onto YouTube. It's for homework, and we're doing like an experiment, and the one that I've chosen is to instantly turn water to ice. My mum's helping me. So the one that we've got a bit of red tape on is like, in fact, I'll explain how it works first. Mum, do you know how it works? My mum hates being on video. So basically, I'll put both of these in the freezer. You don't have to feed me my lines, Mum. I just go off the top of my head. So I'll put them two in the freezer for 2 hours and 45 minutes. I'm going to do a time lapse of the clock so that you actually believe me. And then we'll take them out, and then it'll be like below the super cool or freeze point. And by the way, super cooling is like when you put it in for like a certain amount of time, but like, I forgot what it means. You put it in for a certain amount of time, but it's just below for it turning into ice. So we'll go put these in the freezer. Mum, take both of them. Don't worry, I won't get you in video. Freezer we go. Yeah, no. So that's the time now. Am I getting it? Right. So that's the time now. Yeah, I know. I'm gonna change it after we put them in the freezer.
But you'll not accept that will be.
No, I can stop the clip and edit it together. Just listen to me. I'm accepting it. So here's the freezer, and my mum's like made us put hold on, put the lid on. So we've got the freezer, and we're gonna just sit these in for 2 hours and 45 minutes. And they cannot move at all. And the red one, well, we'll just tell you what happens when it happens. There we go. So we'll shut that. And I'm gonna start a timer and then put my phone on a time lapse. Rightio, am I centered? Yes, I am. I have written down some notes. Right, I've wrote down some notes, like how the experiment actually works. So, what one's first? This one. So, yeah, this is what the supercooling part means. When you put it in for 2 hours and 45 minutes, it'll supercool, but the thing is, it has to be bottled water or purified water, or else it won't work because, well, I've got it here in the notes. So supercooling is when you chill water or just liquids without it becoming solid, so it's still liquid, but when you do something to it, like it'll become like solid, and I'll explain that there. Like, water is normally a liquid at room temperature because the water molecules are all flowing past each other, and that lets the water flow. So, like, if it's like at room temperature and it's like water, all the like molecules will be like flowing past each other, and that lets the liquid actually like move because it's like not ice yet. And when something becomes solid, its molecules all like kind of lock into place. They still move, but are not flowing and rolling over each other, so they cannot flow. So that's kind of like when you freeze it and it becomes ice. All the molecules, they're like still vibrating a bit and like moving, but in fact, why do I have my headphones on? I don't need them. Like, what was I saying? Right. Yeah, they're still like moving and vibrating and stuff. All the molecules are like, they're not moving or anything anymore, so that makes the liquid solid, because if the water's like room temperature, for example, or not frozen, all the molecules are still moving past each other, so like when you move water, that's why it moves, but when it's solid, all the molecules are locked into place, kinda. That's what happens. And then, you need somewhere for the ice crystals to start growing. So I need some kind of nucleation event. So nucleation is, I've got it written down here, nucleation just means to form. And a nucleation event is like when you manually form something. So say, like, you know how the water, when you hit it, it would all turn to ice. Yeah, that's a nucleation event. So if the water isn't pure, here's the part where I was saying, if the water isn't pure, the impurities in the water naturally act as sites where the crystal could start forming. So if it's not pure, then the crystals will form easier, and that will ruin the experiment, because it'll all be ice when you take it out. But if it's pure water, like bottled water, like right, but if it's pure water, then like it has a longer freezing point, so you can leave it in there for longer, like being just about to freeze, but it's not. So yeah. And here I've wrote, so that's why I need to use pure water. And another way to cause a nucleation event is to hit or bang the water bottle. So that's what I was saying. If you hit it, it'll lock some of the molecules into place. Here, I've got it here. That will cause a few water molecules to line up. Like, if I draw something like, hold on, I'll get out like a little bit of paper. I'll just draw it on the back of this. So if I've got a pencil first, right? If I've got tons of like little molecules and they're all like lined up, but one isn't, like this is just a like bad drawing. If them dots are all the molecules, but one of them is out of place, if I hit it, and then all of them will lock into place, like they'll form like the perfect shape or whatever. Like after I've hit it, they'll all lock into place. Like this little one here will have moved up and they're all into place, so that'll give the ice crystal, like it'll start forming. So that's why we need to give it a bash. So yeah, I don't need these anymore. In fact, no, I might actually put them in my homework drawer, even though it's really bad handwriting. So, your boy generic YouTuber did his research. I just realised I shouldn't be saying stuff like that because, well, it's not really bad, but I'm handing this into school. That part. So, that's how the experiment works. So, one of the bottles we're gonna like take out the freezer. Well, both of them. The one with the red tape on it, we're gonna unscrew the lid like really carefully, and we're gonna pour it out into a bowl, and you'll see what happens. And I've already told you what's gonna happen to the other one. Sorry, I just burped. The other one, we'll give it a bash to cause the nucleation event, and all the molecules and stuff will lock into place. Yeah, and it'll start forming ice right before your very eyeballs. So yeah. And also, this has nothing to do with this, but hi classmates. And this is going on YouTube for stuff, so yeah, I'll see you when it's done. I'll wait a few seconds or else the videos will intercept. So, right guys, Friday.
Are you gonna have time to edit tonight?
Yeah, it's fine. Well, maybe not tonight, but I'll have time. Right, can you hold that and record? Right, but it's the other way. Right, be extremely careful with these, because if we do anything wrong, they could end up using. Right, let me get that one. Hopefully we've got the right type of water, because I don't know if we have. Right, and so here's the water. I don't know if this is going to work, because I don't know if Mom's got the right type of water, but hopefully she has.
My name's Tyrone.
I'm
Uniqua. I'm Tasha. My name's Austin. And we're your backyard.
So now, hold on. If we dip, Look. It's all turned to like slush. Well, look at it, you can see it. Look, you can see it all immediately
It's
turn.
not very clear.
Yeah, I know it's not clear, but it did work. So now if we take this one and open it.
I mean, the video is quite blurry.
Oh, I don't know why that's happened then.
Do you want me to
So
stop?
now if we pour this. Oh, this one's turned to ice. I've accidentally banged it. But look. It's all turned to ice. Look, it has worked. I must have gave this one a bang because it was definitely liquid in the freezer. I'm happy. Look, completely frozen. Yeah, it's good. I'm so happy that that's worked though. Hold on. Oh, I'll take the camera. Can you quickly open that bottle? I won't get you in. Oh, yeah, the video is quite blurry. Hold on. I'll give this a wee wipe. Alright, it's blurry. Oh. Oh, no, I mean like open the actual like bottle. So I'm extremely happy that this has worked. Like if we pour some of that out. Right, you take that. Look. Here's a massive bit of ice in there, look. Oh. Ice. And you could see, look, can you hold that? I'm gonna play around with it. Well, not play around. Sadly, the pouring it out didn't work because I must have gave that one a bash on the way out. But I mean, this is one that we could probably try in class. It would be really easy to do. So if I pour all this water out, you'll see that. Hold on. Take the label off. Look, down here, it's ice. Yeah, they can definitely see that. Oh, I just realised we've been recording this the wrong way, so it's going to come out like vertical. Ah, that's okay, it's still an experiment. So, I'm happy that this has worked. Hold on. So, that was my homework project. It was super cool in water and then turning it to ice, and you guys definitely saw in there that it was water, and then we gave it a bang and it all started to like trickle down and turn to ice. Right? We'll use in the next one. More extra time. But restarted. Alright, look. Here's to prove I just managed to get a bit of the ice out. So there, that's proving that it works. Hold on, is there any? Oh! That's cold. Right, you can end it now.